Alright guys, let's go ahead and jump in into where we left off last time. So last time I introduced the Ohm's Law. Ohm's Law is this. V equals I times R. Okay? And so V is voltage, I is the amount of current, and R is the resistance. And we wanted to look at this so that we could really understand what's going on inside this thing. So when we first started, we plugged this into a power source, and we used 5V, or 5 volts for the voltage, and that came out of right here. Okay, one of these, I guess it's right over here, okay? And then we just saw that it would turn on. The light would turn on. Now we want to use this formula now and look at the math to see the amount of electricity or the amount of current that's actually going through the LED to make this thing turn on. Okay, so let's see here. We got V. Now let's go ahead and draw our circuit so that we can go ahead and solve this, all right? So this is our battery, and again we use 5V or 5 volts. And then we have our LED. There's a plus and a minus. And again, let's look at this. I brought your attention to right here. This side has a little black, kind of like a little sausage thing in there. All right, and that was going to be the resistor. So now that we're going to be using this Ohm's Law, let's go ahead and put our resistor into the circuit. All right, and I want you to notice which side of the LED is the resistor connected to. Well, if you look carefully, right, the black wire is minus, and then the red wire is plus. The red wire is the one that has the resistor. So let's go ahead and draw that accurately. The red wire, which is plus, has the resistor. The resistor is simply this squiggly line thing. That's going to go to the 5V plus, and then G and D, or the minus connection, is going to be connected like this. All right, now the resistor, when we designed this thing, I know what the value of the resistor is in there. It's 470 ohm, okay? So what we want to do is figure out exactly how much current, this is I, is flowing through here whenever we make a closed circuit. All right, so what we're going to do is over here, let's go ahead and solve for I. We're going to move the resistor resistance over there. So I'm going to rewrite this. I equals V over R. Okay, I just moved the R over there, and then I flip it over because it makes sense to always say put the what you're trying to solve for on the left side. Okay, so I equals V over R. Let's go ahead and solve for this. V is 5. R is 470. And that equals, I have my calculator here. I'm just going to do this real quick. If you can do it in your head, even better. It is 0.011. And the unit is amp. Okay? Now, whenever we're working with electronics and we get a current level that is so small, that is much less than 1, we like to write it in milliamps, okay? So we just multiply this by 1,000 because there are 1,000 milliamps inside a single amp. So you multiply this by 1,000, you can just move this over 3 times. So this will be the same as 11 little ma, which is 11 milliamps. All right, so when our light turns on here, when we create the circuit with the light, we have 11 milliamps going through there. All right. Okay. So here's a challenge I have for you. All right, using what we've just learned right here. I showed you we have 11 milliamps going through the light. Let's see. I want you to solve for this. So the amount of current, I'm going to call it ID for I dangerous. This is the amount of electricity or current going through a human being that will really hurt, possibly even kill a human being. So this is called I dangerous, okay? 100 milliamps. So about 10 times the amount here. All right? Now you might think, wow, that's 10 times is kind of a lot more, but not a lot more, right? So why is it that we would be working with electronics so close to the lethal level, right? Because honestly, if we want it to be safe, we want it to be at least like 1,000 times. We want the amount of current that we use inside our circuits like this to be like 1,000 times less than the lethal level. But look, it's only like 10 times the difference here. So the thing is here, guys, the amount of current, yeah, it is only just 10 times the difference here. But there's another piece of the puzzle here, right? Another part of the formula, which is this, the resistance. So I'm going to give you the resistance because we're looking at the circuit for a human being now, right? So not for the light, but for a human being. So for a human being, I'm going to say RH. For a human being, the commonly used resistance value is 100,000 ohms. All right. So a little bit about the human body. So the human body on our insides, we're made up of blood and water. So inside there, it's actually very conductive, and that's just a fancy way of saying electricity can travel through that pretty easily. So that means that the resistance is very low. It's actually maybe even lower than this 470 ohm. But that's on the inside of us. But the outside, like our skin and our hair, it's not as conductive. So what happens is that our skin kind of protects us from being electrocuted. So that's why our actual resistance is a lot higher. So 100,000. So on the inside, it might be just a few hundred ohm. But on the outside, with everything together, because we have the skin kind of protecting us, and it's acting as something called the insulator. Insulator, basically, it helps protect things from being electrocuted. It's 100,000 ohms, so all combined. All right. Now, if your body is wet, like if your fingers are wet, you just got out of the pool, this number might go down a little bit. All right. But for now, let's just go ahead and use the resistance of RH of 100,000. So what is VH? So VH would be the amount of volts where if you were to take your two fingers, like imagine this was like the plus of the light and then the minus of the light, kind of like that, and you touched a battery, what voltage of that, if that battery was, what voltage of the battery would really harm you? Okay? So go ahead and solve for that, and then we'll talk about that the next time we meet. All right? Okay, so the other thing that I want to look at is, remember I had you guys take 3 LEDs and we put them into series. And when we put them into series, the light would not turn on. So just to review, we're going to do this. So remember, each light now is like this, right? Each light has a resistor inside in the LED, and I'll just write the plus and minus. So that's one light. Then second light. And third light. plus minus, and then the last one connected to here. So how would we solve this circuit? What's the resistance of this circuit? So it's really interesting. So we have, I'm going to call this R1, R2, and R3. If R1 is 470, let's write the ohm in there, just to be specific, okay? They're all 470. What happens is that the total, to solve for it, is to add all of these up. So all the total resistance is R1, R2, plus R3. So going back to our formula, V equals I times R. V, we still connected it here, right? So to 5 volts. But the lights didn't turn on, and it has something to do with the formula here, right? So let's see. So this is 5. I times, and we have to add up all the R's now. 470 plus 470 plus 470. Okay? So I want you to work it out. What is the current when we have a series connection like this? All right? Now, the amount of current is going to be pretty small, and that will give us a clue as to the minimum amount of current that will allow the light to turn on. Okay? Because if we remember, when we lined it up like this, and we put it in series like this, put it in a series circuit, it would not light up. So that doesn't mean that there's not electricity, okay? Or current, that doesn't mean that there's no electricity flowing through here. There's actually electricity flowing through in here, but the amount of current is so low that it's not enough to turn on the light. Okay, that's a very important thing to realize, because it's not like there's no electricity. If there's no electricity, the light, of course, wouldn't be on either, right? But there's actually is electricity. There's just not enough electricity, and so it's important, because as we start building our robot, there might be times where our circuit's broken, where we have an open circuit where there actually is no electricity flowing through the circuit, or the circuit's not broken, it actually does have electricity flowing, but it's just too small. All right, and this formula, V equals IR, or Ohm's Law, helps us figure that out. So give me I for the series circuit, and we'll talk more about what that means. All right. Okay, so we have that going. All right. So what we're going to do now is we are going to build our very own version of this. So I gave you kind of the easy way in the beginning, which is a good way to start so we don't mess up, right? Where we have the resistor and the light built in. This time, I'm going to show you how to build it without the resistor built in. We're going to have to put the resistor ourselves, okay? So let's draw the circuit again. I know we're drawing it a bunch of times. We're going to get really, really good at drawing circuits, okay? 5V for the power. And then our LED. Okay, now we're going to use our breadboard here. Let me grab my parts. All right, before you had your 5V power source here, all right, it's going to come from here, and you had your breadboard, and then you had this and some power connectors. So let me see if I can find my power connectors. Here we go. We had the power connectors. And then we were good to go, right? Well, the thing is now, as I said, we're going to do the resistor. The word is discretely, so it means we're going to have discrete components. So rather than one thing that has the resistor and the light together, we're going to take this out. And what I want you to do is try to find a resistor, which is a little sausage thing, and then also a light. Okay. So if you look into your kit, I'm going to grab mine. You should find a light, something like this. Alright, and then you have a resistor. Now, you're going to have two different kinds of resistors. You're going to have this one, and you have this one. Alright, so if you look carefully, one of them has a red stripe on it, and one of them does not have a red stripe. Alright, you gotta look real closely. Just to be clear, this one right here has the red stripe. This one up here, let me move that. This one up here does not have the red stripe. So what I want you to do is take the one with the red stripe. And I'll talk a little bit more later about the difference between the two of them, okay? Okay, so now we have our power source. It's going to come from here. We have our resistor, which is this guy. These are our power connectors later, and then we have our LED. All right? Okay, so let's go ahead and make this circuit. Okay, so let's get the plus. So we can take the red wire, and let's go into 5V. There we go. And then let's just put it in a blank row. Very good. And then let's do the GND. One of these, that's good. Alright. Okay, now I'm going to leave this GND pin blank for now. I'm going to do that at the very end. What I like to do, and I recommend you do the same thing, start from the plus and then build around the circuit like that. So if we start on the plus, we've done the red wire. The red wire goes here, so that top row. Now let's grab our resistor, and look at here. The resistor is connected to the top, to the plus, which is the top row right there. Now, which side of the resistor? For the resistor, it doesn't matter which side. Okay, so it's got two sides, just pick any side. Like I could flip it if I wanted to, no problem. So let's make sure they're connected by putting it on the same row. There we go. Okay, now things start getting a little bit more tricky than before because we've got a few more connections to make. Now if we notice, let me get my pen here, okay, we've already made this connection. Now we have to make this connection right here. So the other side of the resistor, so not this side right here, but this side that's sticking out, that needs to connect to the plus of the light. Now what is the plus of the light? If you look at your light, your LED, you're going to notice that one leg, this one right here, is slightly longer than the other one. The longer leg is plus. Okay, the longer leg is plus. Before we had wires that were black or red that would tell us, and the red was plus. Now since we're using the discrete components, we just have to know that the longer leg is plus. And that's going to be a typical thing when you're working with electrical parts. The longer pin is usually going to be plus, okay? So the longest plus, that means that this pin right here needs to be connected to this. So how do we do that? We have to put both in the same row. So I'm going to go ahead and do this. Okay. Do that so you can see. Then do that. Okay. So I want you to notice what I did here. Move this out of the way. I took the long leg, which is the one up there on the row 1, the long leg of the LED, and connected it to the same row as the other side of the resistor. So that's true, and I did what I said I would do, but something's wrong here. And I want you to think about what happened. So I got one part right, which is I need to make this connection. So that's good. But I also did something else that's not good. I also connected this leg to here, because they're all in the same row up there. So that's something that I wanted to show you this, because as we start building circuits with the breadboard, it's a common thing. I do it sometimes too. We don't want to make this connection, right? Because there's no line connecting here to here, so we don't want to do that. So let's go ahead and erase that. And let's make sure we don't do that, okay? Because if you notice, look at this. Both sides, both legs of the resistor, they're in the same row. You're never going to want to do that, okay? So anytime you're putting the resistor down, make sure that the two legs are on different rows. That's not what we want. All right, I'd like to show you some of these mistakes so that it helps prevent you from making them. All right, I'd rather do it myself here on the video so you can see what's wrong. So let me pull this out again. Let's try again. Okay, so we have one, make this connection again. One part of the leg goes into here. Now let's take the other leg and let's put it into a brand new row. That's the key. A brand new row. So like down there, I'll spread it out so it's more clear. And I'll bring it down a little bit. So now you can see one side of the resistor is on row 1, the other side is all the way down, I think it's row 5 right there, right? Or maybe it's 6, row 6. Oh no, it's 5. Okay, so now I can make my new connection. So this new row right here is going to connect to the plus of the light. So take the plus of my light, which is the long leg, this one right here, and stick it into that row. And then for now, I just left the minus, or the short leg, just sticking to the side so we don't get confused. The last thing we need to do is the minus leg needs to go to the minus of the power source, which is the same as G and D, which is this wire right here. So this and this needs to be in the same row. So let's go ahead and do that. And now we're making a new connection. This is a new connection. So let's go into a brand new row. I'm just going to go down here. Let me get it in here. There we go. And then we take this and then stick it to the same row. Here we go. All right. So nothing's on right now because we don't have any power. So let's go ahead and plug in power and hopefully the light will turn on. Let's see. And I don't have any power. So this, I don't have anything turned on. See, that's very interesting. Let's check my connections here. This is actually good that this is happening to me. Let's see here. That goes into there. So everything looks good to me. Now, I don't have brand new parts like you guys, so it is possible that this LED doesn't work, you know? That's it. That is possible. And then let me double check my legs here too. Maybe I messed up the plus and minus. Let me take this out here. Let's see, no, I had it correct. So let me get a different light. Let's try this. Okay, again, the long leg is going to go up here. Oh, and there we go. So this time it turned on. Alright, so that was some troubleshooting, some live troubleshooting that you just saw. I realized that I first have to check my connections, make sure everything's good. I checked, did I put in the light backwards? And that still didn't look good, and it turned out that this LED is bad. Now your LEDs probably aren't bad because they're new. I'm using some surplus parts here, so that happens from time to time. So, but that's an example. So if something does happen that where it doesn't work, check your wires and also check to make sure your LED is in the right way. And then finally, if that doesn't work, you can also try a different LED. All right. So I want you to notice something. Our light is on. Now you can kind of just barely see it, right? Okay. So that's a resistor right here, and that's the one with the red stripe. So what I'm going to do is I'm going to change the resistor to this one, the one that doesn't have the red stripe. So I'm going to change it out. So I'm just going to take this, move to the side, and then put this one back in. Make sure that the legs go where they're supposed to go. There. Now, you should be able to tell, I can definitely tell looking at it, it's brighter now. Alright? So here's a question. It's brighter now, so if it's brighter, do you think this resistor is bigger than this one? Or do you think this resistor is smaller than this one? Alright, so that's something to think about. Number one is the new resistor smaller or bigger? Okay, that's question number one. And once you answer that one, then you can answer this one. Number two. There are two types of resistors. A is 470 ohm and B is 4,700 ohm. Okay, this is a smaller one, this is the bigger one. Which one has the red stripe? In other words, does the 470 ohm have the red stripe, or does the 4,700 ohm have the red stripe? Alright, so this is kind of like a brain teaser, okay? If you don't get it right away, totally cool, no problem. I'm going to go over it with you guys on Thursday, but I want to just kind of throw this out, this circuit here, something that we made, and then have you guys think a little bit after we modified it, right? We changed the resistor. I want you to think about, well, what does that mean? Is the new resistor smaller or bigger? Once you think through that, here's the next step in helping me figure out which one is which. Which one has the red stripe? Does the 470 ohm have the red stripe, or does the 4,700 ohm have the red stripe? All right. Again, give it a shot. If you need some help, I'm going to be with you guys on Thursday, so don't sweat it if this is kind of tricky, okay? It's kind of meant to challenge and make you kind of think a little bit. All right, so that's it for today. The next time we meet, we'll go over some of this, and then we're going to keep going on circuits. All right, we'll see you later.